need a juicer. All right, where whatever fruit you put in, the juice comes out, right? If I put apple, then I'll get apple juice. If you put oranges, you'll get orange juice, etc. Very simple machine. You came and you thought, sir, I'll make something which does something different, right? This is so easy. What you said, you will put apple juice, you will get apple. Right? So this is very interesting, fascinating, right? What you said, sir, whatever you written as the value, if you put this into my machine, you will get the exact input you had here, right?
Right.
So if this is function fx, then this will be the inverse function. All right. So basically what it does is it changes the input and output. Here the input was apple and output was apple juice. But in inverse function, what happens? Input is apple juice and output is apple. This thing is clear?
Yes.
So if ordered PS, what is ordered PS? If I write 1, 2 and I give a function y is equals to x square, what this means, if you put 1 here, then you will get 1 square, suppose.
1 squared.
1. Right? 1 square is 1. If you put 2, then you will get 4. Right? This value represents the input, this value represents the output.
Yes.
So in inverse function, what will happen? This ordered pair will get reversed, 1, 1 and 4, 2. Right?
Right.
This is very clear?
Yes.
All right. So this input thing we call as domain, right? Whatever value you can put in a function, that is called domain. The output thing is called range, right? What variety of things you can have as the output of a function. This thing is clear?
Yes.
All right. So domain and range. So what inverse function does? Inverses the domain and range, right?
Right.
All right. So now let's come to inverse trigo function. Before that, let's start with trigo function. And my handwriting is really bad, like really bad. So if you don't understand anything, yeah, then just ask me. So trigo functions, domain and range. This you have to write it down. All right, very important.
Okay.
Do you know what is the domain of sin x?
No.
No. You can put value in here, right? See how to check domain. Suppose in examination they ask you about something which you don't know. Then think about how to find domain. If I write sin x, is there any value of x which gives us trouble? What do I mean by gives us trouble? Do we get under root negative value or infinite or minus infinite, something like this? Because you have already studied that this is a complex number, imaginary number,
yes.
And we don't want this in a function, neither infinite or minus infinite. Like if I give you 1 upon x, can you think of any value of x which you put here that will give us trouble?
9.
9. 1 upon 9 is good, right? No trouble at all. This is a real number. Think about 0.
Yes. 0.
1 upon 0 is infinite. Right? 1 upon 0 is infinite.
Right.
So we can never get 0 in the denominator. So we cannot put x equals to 0 ever. Right? So domain cannot be x equals to 0. Rest of the numbers are good. So we can put any real value except 0.
Okay.
This thing is clear?
Yes.
So domain of 1 upon x will be everything. That means are all real numbers except 0. Right? This thing is clear, right?
Yes.
All right. So same way we can think for sin x. See, in radian value, no matter what value of sin x you put, just give me a moment.
Okay.
No matter what value of sin x you put, or x you put, sin x will always give a value between -1 to 1, right? Maximum value of sine is 1, minimum is
Yes.
-1.
-1.
So no matter what value you put, if you remember the graph of sine x, it goes on like this to minus infinite and infinite, right?
Yes.
So domain is R. R means all real numbers. Sin x says, yes, I can eat anything. And range is -1 to 1. And this is called close brackets. All right.
Yes.
You know about this brackets, right?
Yes, I know about the brackets.
All right. And cos x, this is also domain is R, range is -1 to 1.
Okay.
Tan x is sin x upon cos x, right? So we can think about this like this. Sin x takes anything, cos x takes anything, right?
Yes.
But we just saw 1 upon x, x cannot be 0. So in here also cos x can never be 0. Because as soon as cos x becomes 0, this becomes infinite, tan x becomes infinite. So wherever cos x becomes 0, we have to exclude that from the domain.
Yes.
Right? We have to delete that from the domain. So when cos x becomes 0 at 90 degree, at 270 degree, multiple of 90 degrees, right?
Yes.
Cos 90 is 0, cos -90 is 0, and so on. So I can say any value except odd multiples, odd number I can represent like this.
Right.
And multiples of 90, pi by 2. Right?
Okay.
90, 3 times 90, 5 times 90, and so on. So odd multiples I can delete, and this is my domain. And range of tan is R, whatever value you can think of. All right.
Okay.
And what about cot x? Let's think about cot x. Cot x is what? Cos x upon sin x. So what do we have to do here?
Yes, sin x cannot be 0.
Absolutely right. So can you, when sin is 0?
Sin is 0 when it's sin 0 or sin 180.
Absolutely right. So either 0, 180, 360, 720, so on, right? So multiples of pi. Right? So I can say R minus n pi, where n is an integer. 1 pi, 2 pi, 3 pi, 4 pi, 0 pi, right? So this will be domain of cot x, and range is R. This is clear?
Yes.
Now sec x. Sec x is what? 1 upon cos x. So what do we have to do here?
Cos x cannot be 0.
0. So what?
And cos x is 0 when it's cos 90.
Absolute, right? So R minus 20 plus 1 pi by 2.
Pi by 2.
All right. Now range of sec x is a little bit different. This is R minus -1 to 1. Oh, sorry, this is not this. Minus infinite to -1 union 1 to infinite. Why this? Because 1 upon cos x. The maximum value of cos x is 1. That means we always have 1 upon 0 point something something.
Okay.
Right? And 1 upon 0 point something something is always more than 1.
Yes.
And same goes for negative, always less than -1. So we can never get between -1 to 1.
Okay.
Right? So this is the range of sec x. Now cosec x, can you tell me the same thing? Domain of cosec x?
Let's see.
Cosec x is 1 upon sin x.
Okay. 1 upon sin x. So sin x cannot be 0. Sin x is 0 when sin 0 sin 90. So R minus n pi.
Absolutely right. So R minus n pi. And range is same as this. Because same concept, 1 upon sin x, right?
Yes.
I hope I'm clear, right?
Yes, you are clear.
All right. This I'm going a little bit fast because this is 11 concept, right?
Yes.
All right. So please note it down.
Okay. What's the domain for secant x? I can't see it clearly.
Is r minus 2n plus 1 pi by 2.
Okay. Okay, done.
All right. Now see, this is input and this is output. So if I write down the inverse function of all these functions, then output will become input, right?
Right.
So let's write that down. Inverse trigonometric functions. We have first one sine inverse x, then cos inverse x, tan inverse x, cot inverse x, sec inverse x, and cosec inverse x. Domain. Now please tell me the domain of these functions.
Domain was R.
No,
Okay.
no.
No,
Domain
no.
of
Okay.
sine
Yes.
inverse.
Okay. So it will
Right.
be the output.
Yes.
Yes. -1 to 1.
-1 to 1, close brackets, right?
Yes. Close brackets. To cos x, same -1 to 1, close
1 to
brackets.
1. All right.
And then for tan x, it will be R.
R.
For cot, it will be R as well.
All right.
For secant, open bracket, -infinity to -1, close bracket.
All right.
Union, 1, close bracket to -infinity, open bracket.
Absolutely right.
Yes. Same for secant x.
All right. Now there is something change in output, right? Range. Why so? Sir, you just told me that input becomes output, out becomes input. Then why this change, right? This question
Right.
must be coming to your mind.
Yes.
What happens is math, if everything was this easy, right? Only what happens? See, this graph of sine x is like this till infinite, right? Now we know sine x is maximum 1 and minimum -1, right?
Right.
Now suppose I take sine x is half, and this is
Okay.
the y for half, and I draw a line like this. What does this line say? When x is this value, 30 degree, sine is half, right?
Okay.
When x is 150 degree, sine is half. Then some value here, sine is half. This is x4, sine is half. For infinite values, sine will be half, right? This is clear. So if I
Yes.
write half comma x1, this is not wrong. Sorry,
Okay.
x1 comma half, this is not wrong. For 30 degree, I'm saying this is x1, this is x2, x3, x4. If you put 30 degrees, then you will get half in sine x.
Okay.
This is right.
Yes.
If you put x2, then also you get half. If you put x3, then also you get half.
Right.
So for infinite values, you will get half. And I told you for inverse function, this just reverses the order. But the question is, half is constant for everyone, but x1, x2, x3 are different.
Right.
So if we have to interchange, then what value should choose? Right? So this problem, how they solved, what they said, like not me, like
Right.
brilliant people, like not at all like me, like bigger scientists, what they said, let's just restrict the graph. What that means, I'm erasing this one and this one, they said. I don't even believe the graph exists after that. What they said, just remove the graphs and draw this graph. This value is minus pi by 2 and this is pi by 2. Now for each value of y, there is only one x.
Okay.
Right?
Right.
Now if you can draw out the ordered pairs and interchange, then you will get exact value for everyone. Right? So what they did, this is called restricting the domain. Right? They deleted the most of the graphs of sin x and looking into only a small part. All right, why they did this? Because this was necessary.
Right.
But they also gave you a very like great power. What this is our choice that we took this much part. If you want, you can take any other part of sin x and we will be cool with this.
Okay.
All right, that is why this is called principal value branch. All right, suppose this was the school principal, the scientist who invented this. Like he said, whenever we talk about principal value branch, you will have to choose this much graph.
Small part.
Otherwise you can take any part of the graph and we will have no trouble. All right.
Okay.
So that is why the output has to be this one, minus pi by 2 to pi by 2 for sin x.
Okay.
We cannot write r, because if you write r, then the outputs are
values
minus 1
all
to
different.
Yeah, absolutely right. Right, the values keep repeating. All right.
Yes.
This is clear?
Yes, I got it.
So yeah, that is why we have to write the output of this as range as minus pi by 2 to pi by 2.
Pi by 2.
I hope why this is clear, right?
Yes,
why this is
this
happening.
is clear.
All right. And same for cos x, they said 0 to pi.
Okay.
All right. Why so? If you remember the graph of cos x, this one is easier from this to this.
Okay.
All right. Because if you take from minus pi to pi, this one, we have 2 x's for each one, right?
Yes.
So we can only take for one. So that is why they took 0 to pi. All right.
Yes, got it.
For tan x, they did the same thing, minus pi by 2 to pi by 2, but open brackets, because as pi by 2 and minus pi by 2, this becomes infinite. So they had to remove minus pi by 2 and pi by 2.
Okay.
And for cot x, 0 to pi, same thing, open brackets. For sec x, 0 to pi, close brackets, but removing pi by 2, because at pi by 2, this becomes infinite.
Okay.
And for cosec x, minus pi by 2 to pi by 2, but removing 0 from it. All right.
Okay.
So if you can like look at the pattern, sin x, tan x, and cosec x, almost similar range, right?
Right.
And cos, cot, and sec have the almost similar range. And this you have to remember. Like this is a must. All right.
Okay.
So please note it down. Ayman, just give me 2 minutes, all right?
Okay, no
I'll
problem.
back in 2 minutes. Yeah.
Okay, I'm done.
All right. So this is the domain and range of inverse trigonometric functions. This you have to remember. Then you have to remember few properties. Properties are very easy to remember. All right. But
Okay.
you have to first remember domain and range to solve questions. So first property is sine inverse sine theta is theta. All right.
Okay.
Cos inverse cos theta is theta. But you have to keep one thing in mind. See, no matter what value you put in here, sine inverse will always return its output, its range, right?
Right.
And if theta is the output, then theta must belong from its range,
Sine.
right?
Right. Which
So
is
output of
minus pi by 2 to pi
absolutely
by
right.
2.
So this is the condition you have to check. If you have to apply this property, then you must check whether theta lies between minus pi by 2 to pi by 2. All right.
Okay. Okay.
Same for cos inverse, tan inverse, and everyone. They has to be from their respective output or range. Don't repeat output, right?
Okay.
This is not the
Range.
technical term. This is range. I just use that to make them understand.
Okay.
So tan inverse tan theta is theta. Theta lies between minus pi by 2 to pi by 2. Cot inverse cot theta is equal to theta. Theta lies between 0 to pi. Sec inverse sec theta is theta. Theta lies between 0 to pi minus pi by 2. Cosec inverse. Write it down. All right.
Okay.
Nothing a lot to explain in here.
Do I have to write the range as well?
Yes, it's better if you write like
Okay.
while revising. You have to keep that in mind, and also good for practice.
Yes, I'm done.
All right. Second property, just the opposite of this. Sine of sine inverse x. What will be the answer here?
Theta.
X, right? Sine of sine inverse
X.
will be
Okay.
x, cannot be theta.
Okay.
And here x has to be from the input of sine inverse x, right? Of the domain
Minus 1 to 1.
minus 1 to 1.
Okay.
Same for cos. You can write down with me. All right. Nothing a lot to explain again. The proof is also very easy. I'll explain at the end of the class if you want. Otherwise, you can look at the book. Very simple proofs. we are going to learn how to use it in questions.
Okay. Okay, done.
All right. So let's jump into questions. Sine inverse sine pi by 3. Cos inverse cos pi by 3. Sine inverse sine 2 pi by 3. Let's solve these questions. All right. Which property is this?
Sine inverse into sine theta.
Not into. This is not into.
Okay.
All right. See, we have to put some value in here, right?
Yes.
That value itself is sine theta.
Okay.
Or like body and soul, right?
Okay.
You have to, like, soul is inside the body,
Right.
so that way this is not multiplication. All right.
Okay.
Yeah. So what is the answer here?
Pi by 3.
Pi by 3. But first you have to check if this angle lies between minus pi by 2 or pi by 2. This is the necessary task.
Okay.
All right. What is the value of pi by 3? 60 degree.
Yes, 60.
So 60 degree lies between minus 90
to 90. Yes.
So yes, this is true. So we use that property directly. All right.
Okay.
So can you answer for this?
Yes. Pi by 3.
Pi by 3. Why so?
It's because the property.
No, pi by 3. First you have to check. Pi by 3
Okay,
lies between 0 to pi.
0 to pi.
All right, because we have cos here. So cos is 0 to pi. Pi by 3 lies between 0 to pi. Then you can use the property. Now what is the answer here?
First we'll have to check for sine.
Right.
If it is so 2 pi 90 by 3, 60. Yes, it does lie between the range of
sure. What is the value of 2? What is the value of 2 pi by 3?
60.
Are you sure?
2 pi. Oh no, it's 2 pi. Pi is 180, right?
Right.
Yes, so it will be 360 by 3, which is 12. 120.
Right. 120. Right.
Yes.
Or pi by 3 is 60. 6 times 2 is 120. Right.
Okay.
So 120 does not lie between minus pi by 2 to pi by 2. Right. And this is where the teachers trick you. Right. So what to do here? What we can do is convert this angle into something that lies between this value. All right.
Okay.
We are going to convert this 2 pi by 3 into something that lies between this. So how we can do this? Very like standard steps. Sine inverse sine. Write this 2 pi to the nearest value of 3. What I mean by this? Can I write this as 3 pi minus pi? Yes or no?
Yes.
Divided by 3. All right. I did not change anything. See, 2 pi, 3 pi minus pi is 2 pi.
Yes.
I'm just rewriting stuff. So this is sine inverse sine. Now break it down. Can I write this as pi minus pi by 3?
Yes.
Right. Now you have to say, if you know this formula, sine pi minus theta, what happens when we write sine pi minus theta?
I
You
don't
don't
know.
know?
No.
All right. So let's dive into this because this is very important. Only two cases are there. Either you will face, or four we can say, sine pi minus theta, sine pi plus theta, sine pi minus 2 plus minus theta. All right. The same thing for here, and same thing for all the functions. Sine, cos, tan, cot, no matter what they give,
Okay.
this is the same process for each one. You know this, there are four quadrants:
Yes.
all positive, sine positive, and this is tan positive and cos positive.
Okay.
What this means, this angle is from 0 to 90.
Yes.
This is 90 to 180. That means 0, pi by 2, pi, 3 pi by 2, and 2 pi. All right.
Okay.
So from 0 to 90, all positive, 180 sine positive, 182, 270 tan positive, 270 to 360 cos positive.
Okay.
What this means, if you put any angle from 90 to 180, that means 120, 130, 145, 165, anything in sine, then that value will be positive.
Okay.
All right. And if you put any of this value into cos or tan, then they will be negative.
Okay.
This thing is clear.
Yes.
And if sine is positive, then cosec is also positive, because sine is 1 upon cos, right? 1 upon
Yes.
cosec. Same for tan and cot, and cos and sec. All right.
Okay.
In short, we read this as ASTC: all positive, sine positive, tan positive, cos positive. This is clear.
Okay.
All right. So
Tan
yes.
and cos will be positive or negative?
In which, see, we have divided this into four quadrants: 0 to 90.
Yes.
If you are moving like this angle will be 0 to 90, right?
Yes.
This angle will be from 90 to 180, right? 180 to 270, then 360, right?
Okay.
So we have divided all the angles into four categories. All right. So if you put any angle between 0 to 90, any angle 45, 60, 75, then all the functions will be positive.
Positive.
Sine 45, cos 45, tan 45, everything.
Okay.
But if you put any angle from 90 to 180, like suppose 120, then sine 120 will be positive, cos will be negative, cos 120 negative,
Okay.
tan
Tan will
also,
be negative. Okay.
right?
Okay.
Cot
Okay.
will
I
be
got
negative
it.
and sec will be negative. All right. And same
Okay, I
thing
got
for each quadrant.
Okay. I got it.
All right. First draw this one, then I'll explain what to do further.
Okay. Okay. Done.
All right. Give me a moment. All right. So this thing is clear, right? What is the
Yes.
quadrant means? All right. Now what you have to remember, two things you have to remember now. If you have pi plus minus theta, right? And pi means again 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, minus 2 pi, minus something, right?
Yeah.
Then sine will remain sine and write theta. This sine pi minus theta or sine pi plus theta, this will become sine theta. Sine theta.
Okay.
But if you have pi plus 2 by theta, that means 2n plus pi by 2, that means 90, 270, and multiple of 90, right?
Okay.
So if you have pi by 2 plus minus theta, then sine will become cos theta.
Cos theta. Okay.
All right.
Yes.
That is why, in fact, this is the reason why this is called cos. This is sine, this is cosine, complementary of sine. Complementary means two angles meet and they become 90 degree. That is why this is called cosine, because 90 plus minus theta becomes cos theta.
Okay, I got it.
All right.
Yes.
So if you have multiples of 90, then the function changes to its complementary. Tan becomes cotan, cot. Sec becomes cosec, cosec. All right. But if you have multiple of 180, then sine becomes sine, and you have to write theta. Now you have to check for plus and minus thing. How to check that? Suppose you have pi minus theta. Pi means stand at this line, right?
Yes.
Minus theta means you are moving a little bit backwards. Then you are standing at second quadrant, right? Pi minus theta means second quadrant. At second quadrant, sine is positive.
Positive.
So this will be positive.
Positive.
Because the question was in sine. All right.
Yes.
Now pi plus theta, you are standing at here, moving a little bit forward.
So it will be sine is negative in that quadrant.
So this will be minus sine theta.
Okay.
All right. And same thing for 90 plus minus theta. You are standing here, moving here or here or here or here. And you have to look accordingly plus or minus. All right.
Okay.
Absolutely clear?
Yes, completely.
So now let's see here. Sine pi minus theta will be sine theta.
And
right?
Yes, it will be positive.
Absolutely right. So sine inverse sine pi by 3 I can write.
Okay.
Pi minus theta. This is pi minus theta. So this sine pi minus theta becomes sine theta.
I'm sorry, can you repeat it again?
All right, let me explain this. Sine, we have pi minus pi by 3, right? And this is sine inverse. Yes. I'm just looking at this quantity.
Okay.
This I can write this as sine inverse sine pi minus theta. Yes or no?
Yes.
And sine pi minus theta I just saw that sine theta. So
yes.
This is sine inverse sine theta.
And then
this whole quantity is sine theta, right?
Yes.
So sine inverse sine theta, that means we have the value sine inverse sine pi by 3 because theta value is pi by 3.
Pi by 3. Okay.
And now we can see pi by 3 lies between minus pi by 2 to pi by 2.
Yes.
So the answer will be directly pi by
3. Okay.
This thing is clear?
Yes.
Yes, I know this is a bit complicated because we have to know the 11th topic also. All right.
Yes.
And as you have already thought about this, that the teacher will always put questions like this. So you have to know how to change these angles. All right.
All right.
All right. So note it down, all three questions and the method also.
Okay, I'm done.
All right. Solve this question. Cos inverse cos 2 pi by 3.
Mhm.
Next question is cos sine inverse sine pi by 6. All right. Always try to break angles into something like this. All right. Closest to the denominator. If you have 3, then either 3 pi minus pi or 6 pi minus pi and so on.
Okay.
All right. Solved it.
The first one, yes.
Question, what is the answer?
Pi by 3.
Pi by 3. Why so?
Because 2 pi by 3 does not lie in the range 0 to pi. So we had to change it, rewrite it.
What is the value of 2 pi by 3?
120.
So 120
it
does
does
not.
It
right?
it does, yes.
So you are always like making a mistake at 2 pi by 3, right?
Mm.
So please be careful about this. I knew you will right do this again.
Okay.
So please mind this. All right.
Okay.
From the
So
next time, remember this pi by 3 is 60. 2 pi by 3 is 120. All right.
Okay. So the answer will be just 2 pi by 3.
2 pi by 3. Yes. And in here, what will we do?
Here, pi by 6 is 30 and 50. Okay, this does not lie between minus pi by 2 to pi.
Absolutely.
It's 150.
Absolutely right. So we have to change this.
Rewrite it into 6 pi minus pi.
6 pi minus pi by 6.
By 6, which will be a pi minus pi by 6.
Absolutely right.
And then sine inverse of sine theta. So it will be sine pi minus theta property. So it will be just sine inverse sine theta, which will be theta. Theta is pi by 6.
Absolutely right. So this question you are doing perfectly fine, but at 2 pi by 3, you are facing issues. All right, yeah. So please note it down. Now next question. All right, this one. How to solve this? We can write this sine inverse half as sine pi by 6.
Yes.
Right. So this will be pi by 6.
Okay.
This is clear or not?
No, it's not clear actually.
All right. See, we know half is when sine is 30 degrees. Sine 30 is half.
Okay.
So I can replace half with sine pi by 6. Pi by 6 is 30.
Okay, okay.
And this does lie between minus pi by 2 to pi by 2.
Yes.
So this will be the answer.
Okay.
So can you tell me the next one?
root 3 by 2.
Use your pen and paper also.
Okay. I can't remember the value.
You don't remember the values. That is
No.
very sad to see.
I feel
In the next class, in the next class, you have to remember the values, all right? Right? Again, at 30 degree, cos 30 is root 3 by 2.
Okay.
So what will be the answer?
30 pi by 6.
Pi by 6. Let me write down the values for you of pi. All right. 0 is 0. Pi by 3, pi by 6 is 30. Pi by 3 is 60. Pi by 4 is 45. Pi by 2 is 90. All right.
Okay.
So it's better if you remember this, because you will have to deal with radians. All right.
All right.
So is this clear, whatever you studied in today's class?
Yes, it is. It's very clear.
Sure, right?
Yes, I'm sure.
It will not happen that if tomorrow I ask you, you will like, sir, I don't remember anything. Like,
no.
No?
I understood everything.
All right, then. See, if you revise once, like all the domain range and all the formulas, then you will be absolutely clear. All right. And I like to do things like, you should not have to revise before the exam. That's not my philosophy at all. I believe when the child is playing cricket before the exam, then I am successful. Right?
Yeah.
So if you revise after this class once, then you will be perfectly clear about everything. All right. So please do.
All right. Okay.
And remember the values, and remember this 2 pi by 3 is lies between 0 to pi.
Yes.
All right.
Okay.
All right, then. See you in the next class. Ayman.
Okay. When will be our next class?
You will be joining TT batch, like Tuesday and Thursday batch. So tomorrow.
Tuesday and Thursday. Okay. And in a day, I will have one class, right? Or two classes?
I believe only one subject is taught in a day, per day.
One day. Okay. Because I would like that, because no, today I missed my physics class at 1 hour before this because I couldn't attend. That's why.
Yeah, this was a trial class, right? So trial class, they put a lot of classes maybe, but subject wise, you can talk to the team also. They will arrange the classes in such a way that they will be like according to you. All right.
Oh, okay. Thank you so much.
No issues about that. All right. But I hope I was clear to you.